Hey guys, welcome back to the session 16 of Java Full Stack Made Easy. So in the previous session, we discussed about the rules for overriding. Also, we talked about the concept of inheritance, right? So we have also seen how Java does not inherit the constructor, but it invokes the constructor. And we have seen how do we make use of a super keyword to call the parent class constructor. And we have also seen how do we make use of this keyword to call the constructor of the current class. So if you have not watched that particular video, I encourage you to go and watch that particular video. So now what I'm going to do is I will be introducing you with some more enhanced or advanced concept in terms of inheritance itself. So for that, first of all, I'll close up everything that I have written before. And now let's create some more enhanced inheritance concept, and we will learn another keyword in Java, which is final. So now let's create a class first. Let's create a class and let's call that class as maybe, let's just say a class student is something which I want to create. Let's say a class student I'm creating. Public. If I wish to add a main method, I can add a main method. So as for now, what I'll do is I'll just add up a main for your convenience. Yeah, main is added. Now let's increase the size. Yeah, looks good. Now in this case, what I'm going to do is I'll create a variable called a string name of the student. Okay, so name of the student, let's say I'm initializing the name as ABC. And obviously we generally don't do this. We generate the getters and setters and then we set the values and we get the values. That's what we do, right? But to make it easy for you, I'm just initializing the values here. So sometimes I tend to do the things to make things easy for you. But when you're developing a real world application, always remember you don't do things like this. You always generate the getters and setters. If you want to get the value of that variable, use a getter. If you want to set the value to it, you use a setter, or you generate the constructor using fields. So something that we have already used in our previous session. So as of now, I'm just keeping it simple. I've created a variable called as ABC, and that's the variable I want to print out in my main method. So since main method is static, so I have to use an object reference for this. So what I'll do is I'll just create one function here. Let's call it as void show or display student details or something like that. Okay, show student data or something. Okay, so this is the function I am creating, and in this case I'll just be adding a system.out.println, and the same function I'll call system.out.println. the name is what I'm calling, and I'll just go ahead and do a new student dot show student data. I have already explained you how do we make use of this one liner, and then what is the difference between creating multiple objects and calling the functions and all. So in this case, since there's only one function being used in this particular class, so there's no need to create an object for it and then use the object reference and call this particular method. So I hope that you have already watched my previous videos, and from there you have already understood this. If not, then watch this entire series. Do not watch it in between. So let me save this, and let's just see the result of this. So obviously the name is ABC, and I'm creating a function for it, and I'm printing that particular variable, and I'm calling the same inside the main function. Now I want you to think over this. Name of the student can be changed, right? So in real world, obviously, even in the real world, you can change your name. That is possible. But imagine a situation if you enroll your name into a class, or maybe you enroll your name into a school. So the school gives you a registration number, right? And if you are in a classroom, then the class gives you a roll number. Can those roll numbers be changed? Or maybe your registration numbers be changed? It cannot, right? The registration numbers once given, that's it. You cannot change it. Similarly, if the roll numbers of a student is given, that's it. That's a final roll number. The roll number cannot be changed. Similarly, if you take another example, when you try to open a bank account, so at that time what happens? You go to a bank, they give you a bank details, they give you a form, and then they ask you to fill your details. So your address, when you give the address, your address might be changed, and you're giving your email ID, your email addresses can be changed. You're giving a phone number, your phone number can be changed. But when the bank gives you a bank account number, now this bank account number is final, it can never be changed. If you want your bank account number to be changed, what you have to do is you have to delete the entire bank account, recreate your bank account. So there are certain things in even in a real life which cannot be changed at all. So when we want things like that to be included into our application, we have to make use of something called as final. So this final keyword can be applied on a variable, it can be applied on a function, it can be applied on a class. So we will see in details what happens to this when we apply it to a function, when we apply it to a variable, or when we apply it to a class. So here I am applying it to a variable. Let's see what happens if I create a variable as final. So let's just say final int roll number equals to any roll number I want to give. Let's say I want to give the roll number as 50, and that's it. So now what I'm going to do is, in this example, I'll try to change the name is equal to, from ABC I'm making it XYZ. So this is completely valid. But when I try to do something like roll number equals to, now from 50 to 60 I'm trying to change it. The moment I try to change it, no, it does not accept that. It gives me an error. You cannot reinitialize it. So the final field student roll number cannot be assigned. So you cannot assign a value to a final variable. Not just assign a value, you cannot reassign. Okay, you can assign a value. Here I have assigned the value, right? We cannot reassign the value. So this statement might give you an error. Because of what? Final variable once initialized cannot be changed. So it's what? It's constant. It becomes a constant. So whenever you mark a variable as final, so it becomes a constant. So let me put this into the repository, and I hope that it is completely clear to you. So this is our day 16. I'll add a repository for the same. Here goes a new repository, day 16 slash, and then demo1 final variable, right? So I hope that you have got to know what exactly is a final variable. Now let's just see the rules that are associated with a final variable. There are certain things which we should know while creating a final variable, and what those rules are all about, and what is it all about. So first point, let me clean up this name and everything, because I hope that I have compared both of them and I have already shown you how it behaves. So let me clean that, and this show student detail and everything again. Yeah, let it be as for now. Let that only print system.out.println roll number as for now. Okay, roll number. All right, so the rule number 1 now. I'm not initializing this variable here, right? And I try to initialize that roll number here. Roll number equals to 60. So when I try to do this is not possible. A blank final variable, a final variable whose value is not given, a blank final variable cannot be written like this. You cannot do this. Now why is that? That's because, see, in general we know that in Java, for another point I should add here, this gives us an error, and also see, this gives us an error. Now why is that? See, if this variable was not final, it gets a default value as 0, right? Int roll number will be 0. The moment I add final to it, it does not give me any value. It is actually giving me an error. It says that this final variable has to be initialized. So if I put my cursor on this, it says the blank final field roll number may not have been initialized. So this blank final variable has to be initialized. That means, so point number 1 is that final variables don't have a default value. That's point number 1. Point number 2 is that must be initialized, right? So because they don't have a default value, it must be initialized. Once initialized, it's final. So must be initialized, and once initialized, it's final. Okay, so now, is it compulsory to initialize this variable when we declare it? That means, can we separate the declaration and initialization of final variable or not? So the answer for that question is yes, we can. But it is not allowing us to do that, right? So I say to you that we can separate this declaration and initialization, but here it is not allowing us to do that, right? But there is a catch here. What is that? So if I create a constructor for the same, you notice that the moment I create a constructor, the error is shifted to constructor. That means our Java compiler is intelligent enough. So Java knows that this user has created a final variable. So because the user has created a final variable, it means that the user has not initialized it. So because the user has not initialized it, the compiler also knows that final variables don't have a default value. So the user either has to initialize that variable right after declaring it, or the user has to initialize it inside the constructor, right? So here the error is because of this, not because we have wrongly defined the constructor. The error is only because of this. So if I put a comment on this, the error on the constructor will be gone. So that means, again, it proves you that the error on that constructor is only because of this final roll number. So this is how a declaration and initialization of a blank final variable can be separated. So I can do this. Roll number equals to 60. This is all fine. So, and this will print me 60 when I try to run this, and if I again try to reinitialize it, it will not. So if I try to do a roll number again, roll number equals to 70, obviously it is going to give me an error because I cannot reinitialize it. Only once, when I initialize it, once it's final, so it cannot be changed. So this way we can separate the declaration and initialization of a final variable. When we don't this type of final variables are called as blank final variables. So let me just copy this and put this into the repository. Demo2 blank final variable. Done. Looks good. Now what I will do is I'll just try and put this into a constructor itself. So when I put it inside the constructor, or maybe what I'll do is I'll try and put this inside a function itself. So when I put it inside the function, that means a local final variable. See, its declaration and initialization can be separated, and the initialization is not in the constructor. So that means the blank final variable is something that is at the instance level, not at the local level. So why is it not giving an error here? If you think it on this, then you will understand why it is not giving an error. The clear cut reason is what? Because it's a local variable. Local variables don't have default values. So because it knows that local variables don't have default values, even final variables don't have the default values, so it has to be initialized before its use. So that's why it is not giving you an error here, but in the previous case it was giving you an error. So for local final variables the rules are different. For instance final variables the rules are different. So let me copy this as well and put this into the repository as local final variable. So that also tells you that a final variable can even be local. Now when I say local final variable, so when I say that a final variable can be local, so what type of variables cannot be local, right? Let me give you an example for that. If suppose the variable is declared as static, it cannot be a local variable, right? So you might also say a function is non-static. Why are you creating a static variable inside that, right? So let me go ahead inside the main method and try and give a static variable. So you cannot create a local static variable. Static variables cannot be a local variable. That's because of what? Static variables are class level variables. So you cannot create a class variable and at the same time you say that it is the local variable. It's completely illogical, right? So static variables cannot be created as a local variable, but final variables can be created as a local variable. And also one important point when it comes to the naming convention, if suppose it's a final variable, then what happens is generally we create it like this. So whenever you see a variable with all caps, you know that it is a final variable. Okay, so I hope that now you have got to know a lot of rules associated with the final variable. What need to be done when a final variable is created as an instance variable? Then what should be done when a final variable is declared as a local variable? Then what should be the naming convention for the final variables? Rules for the final variable. So I hope the concept of final variable is clear. Now before I move ahead to the final methods, I would like to just highlight one very important thing for you. Now, how does Java internally create this final variable, right? So this is something that comes into our mind naturally. How did they create variables? Because end of the day, what is a variable? A variable is a name given to a memory itself, right? So memory can be changed. So how are they making the memory as final? That means they are reserving a memory, but it should not be modified, right? So the easiest answer for that is that this final variables go into a special memory. Now what is that special memory? ROM, read only memory. So final variables, they reserve their place at the read only memory. So because the memory is read only, you cannot modify it. So it is as simple as that. So I hope that now the concept of this final variable is clear to you. Now coming to the next concept, this final can also be applied to a function. Now what is that, and what happens if the final keyword is applied to a function? So in that case, what happens? Okay, so let me take the same example. So there are students in our school. So as for now, what I'll do is I'll remove it completely. So there are some students into our school. So let's say the student have taken the admission into science department. Okay, students basically in college, not schools. Schools don't divide the student based on the science student, art student, and commerce students, right? So let's say we have science students. That's a function. That's a function I'm creating. So let's say void this particular student of science student. So what I'm trying to do is I'll be creating for student. Let's say there's just students, and there is some rule that we have defined for all the students. Let's say this is not science students. Let's say what we are doing is we're saying follow the discipline. Okay, hope that's correct. So I'm saying the student should follow certain discipline. Now what's that discipline? So when a student comes to the school, they have to follow certain rules. They have to follow certain discipline. That is what, let's say the student has to wear school dress, or maybe let's call it a school uniform. Okay, that's the rule. And suppose, for example, there are different type of students in our school, or maybe college. School uniform, or let's just call it as school or college or whatever it is. Now there is another student. Obviously the student means what? The extension of this particular student. The extension of the student would be what? The extended class. That means a child class. That's what we have learned in our previous session. So I am creating a class again. Class what student? Science student. So this science student, obviously they can override this particular function, that is the void follow the discipline, and the science student says that we will not follow the rule, or maybe we will come in casuals, right? That's correct. So the science students might say that, the math students might say a different thing, and the art students, or maybe any type of students, they might say that I don't want to follow that rule. I want to follow my own rule. So there are certain situations where you don't want to change something, right? So even if your class is extended, you don't want to change certain things. Other things they can change. There are certain things which cannot be changed at all. Like this following discipline, no type of the student can change it. Like this is an extension of the student itself. Okay, so this is how it is. So what these science students are saying that they will come into casual. So as for now, it is correct. As of now, in this case, it is correct itself. So what I will do is, first of all, I'll not mark the student as public. So let's just create it as a class. I'll create a public class and call it as a student service. Now the reason why I'm creating this class as public is because I want the main method to be here. I don't want to create a main method inside the student class. So this is something which we have already discussed. There can be only one public class per file. So I am creating that for student service, and the public class name and the file name should be same. So that's why I'll change that file name now. So I'll click on this error. So whatever error is being generated. Now what I want is, I want to rename the file. Okay. So just rename it. It has to, in fact. It's not changing. Anyways, what I'll do is I'll refactor and change it to the student service. Okay, now that error should be gone. Public class student service. Oh, it has changed all the student to student service. So let me just remove that here. I think I've selected everything while changing it. Anyways, so let's just go ahead, and wherever it was student service, now looks good. So now I'll bring in the main method, and I'll create the instance of a normal student. So students s is equal to new student. So student s dot follow discipline. So the students are saying what? So when they are following the discipline, has to wear the school uniform. But the same student, if I create something like this, for science student, s is equal to new science student. So whenever I say science students, they are not following that, right? S1 dot follow discipline. So when I say that, so at that time, they say what? No, we will come in casuals is what they are saying. So if I extend more students, like not just the science student, if I go for the art student or maybe the commerce student and all, they can like they might like maybe there's something like void attend for lab. Okay, so there's another function that says attend for lab. So the student should attend for the lab. Students must attend the lab. Okay, so I have science student. What I'll do is I'll also create an instance of an arts student. So I'll go here, and now for the science student, I'll also have the arts student. So arts students are also student. So what they're doing is they're basically overriding all of this, right? So I can put an override annotation on top of this. This is what we have already learned before, right? So if I put an override, so it ensures that the below method is overridden for sure. So discipline is overridden, and let's also try and override this attend for lab. So science students, when they are attending for the lab, they will attend for the lab. Yes. At the rate override. So maybe the science student says we don't override it, we will be attending the lab for sure. The art student, what they do is they will try and override it, attend for lab. So the art student would say lab is not for us. Okay, not for us. That's fine. So looks good. So when I have this art student now, see both science student and art students, they are the child of the same class itself. Art student, let's call it as A1. So see, in my case, I'm creating it as A1 or maybe S1 and all. So what you have to do is you have to create it as art student itself and science student itself. That will actually give you a meaningful object name. Or in this case, what I can do is a better approach of creating this object would be creating of this object like this student instance of this parent can be created like science students equals to new science student. So this is called as dynamic method dispatching. We will learn the rule about dynamic method dispatching, what it does and all. We will focus on that later, but as for now our focus is on what? Our focus is on the other thing, that is how do we create an instance of this. So let's create the instance science students, and there are art students. Okay, so for science students, if I say follow discipline, and for the science students again I say what was that, attend for lab. So science students, it's an object of both are the object of the same class itself. Okay, although this is referred by the different childs. This is for the art student. So let me just run this and give you that. We will come in casuals is what those science students are saying. Students must attend the lab, so they will be attending the lab. And when it comes to the arts students, so let's call that arts student dot follow discipline, and arts students dot attend for the lab. So when I save it and test it now, so it says we will come in casual, lab is not for us. So you can notice that students must attend the lab. This is not overridden, and this is the overridden method. So both of them are saying that they will come into casuals itself. Both of them has overridden that particular method. If suppose art students don't override this method follow discipline, at that time they will come in the school uniform. You can see this for art student has to wear school uniform. So in scenarios, in situations like, what is the logic or what is the agenda behind showing you all of this? The agenda is simple, clear cut. What is that? There are two type of students. What type of students? Science students and art students. And there are certain set of protocols which everyone has to follow. That is, these are the rules that has to be followed. But what is happening in this situation is that science students are not following that discipline, but the art students are following the discipline. So in that case, in such cases where you don't want something to be changed, in that case itself you will bring in the concept of final methods. Okay, when I say final void follow discipline, you can see that science students cannot say that we will come in casual. So this will not be allowed. Overriding will not be allowed for the final method. So now it looks all perfect, right? So the students handbook says what? The rule book for students says you have to follow the discipline, that is has to wear the school uniform. Whatever students they are, be whether they are arts, science, commerce, whatever students, they have to follow the discipline, right? That means they have to wear the school uniform. But this attending for the lab is optional. For science students it is compulsory. They have to attend the lab for sure, compulsorily. Art student can override it and they may say that lab is not for us. Commerce student also can override it and say that the lab is not for us, right? So here is a best use case for final methods, right? So there are certain things which you don't want your child to override. In that case you will mark the method as final. So I hope that the concept of final is very much clear to you. A method declared as final cannot be overridden. I'll give you this example. Hope you have already related that example. And in this example, if you have not understood what is the student, new science student or art student, so if you are confused on that, what I will do is I'll create it simple in a simple way for you. I'll create the object of student as student, art student as art student. So in my later sessions, I'll actually explain you what this is all about and how can we do that. That is, the concept is called as dynamic method dispatching. So in my future tutorials, I am going to explain you what is dynamic method dispatching, in what situations we have to make use of this dynamic method dispatching, what are the rules of dynamic method dispatching. So as for now, you just consider that the two type of students that we have, science and art students, there is one rule that all the students have to follow, which is that the students have to come in the school uniform, whether they are science or art students or commerce students or any student, they have to come into the school uniform. So that is why what we have done is we have made this school uniform concept, the follow discipline method, as final, which cannot be overridden by anyone. whereas attending the lab is an optional thing. Depending upon the type of the student, they will say whether they want to attend the lab or not. So in this case, since this method is not overridden, so they will be attending the lab, science students. And since the art students don't want to attend the lab, that's why they have overridden it and modified it. Hope you have got a clear idea about the final method. So the conclusion is that if a method is declared as final, it cannot be overridden. Demo 4, final method. Hope you are also relating the examples that I'm choosing here. Okay, and I'm trying to put all real life examples into picture so that it will be easy for you to map the things and understand the concept of final variables, final methods. Like in the previous example, I gave you an example of a roll number which cannot be changed, a bank account that cannot be changed. Similarly, here in this example, I gave you the follow discipline rule, that is a student has to come into a school uniform, so that cannot be changed, right? So such things can be marked as final. Now, what are the rules for final method? We will see some of the final method stuff there, and then we will move to the final classes. Now, what are the rules? First of all, final method, when you are declaring a final method, so that cannot be overridden. And please ensure that if you write the final method as private, so in that case, what actually happens is that the method is private, right? It cannot be inherited. So since the method cannot be inherited, it cannot be overridden. So although the syntax is allowed for you, it says private final void discipline, the syntax is allowed, but makes no sense at all. Why does that doesn't make sense is because this method follow discipline is not visible to this child. So when you try and call the follow discipline, it's not visible at all because that's private, right? The method follow discipline from type student is not visible. So please ensure that when you are creating a method as final, you don't mark it as private, or marking it as private means that it is only visible to this student itself, right? So that's one thing, but the syntax is allowed in Java, and this can be one of your interview question. It will not give you any compilation error until and unless you call it. Okay, if you're calling it with this particular object, student object, it is fine. But if you're calling it with the child object, you'll not get it. See, this is an object of child created, right? If I create an object of student itself, directly if I create the object of student s is equal to new student, and then I try to do a s dot, what was that final method? Follow discipline, right? So, oh, sorry, that's because it's a private method, right? So I'm trying to call it in student service. I can call that particular method private method here itself. So if I try to call the follow discipline here, it's all possible, but I cannot call it in any other class. Even the child cannot access it, child cannot see it. So because the child cannot see it, there's no point of marking it as final, but the syntax is completely valid in Java. So that can be one tricky question that might be asked into OCGP, a valid one. Now the next thing is that whenever you use final, so at that time overriding is not possible at all. So hope this is clear to you. Now moving ahead, what is a final class? So if a class is declared as final, so at that time it cannot be modified at all. So let me just give you one example for the same. So I think I've created a calculator. Yeah, calculator.java. I'll take the same example. Let's remove this. It is calculator.java demo. Yeah, everything. I'll just remove it from here. This is a calculator. I'm creating a calculator class, and what I'll do is this is just a simple calculator where I would like to have some methods like void add, and maybe the user is going to give me two arguments here, int a and int b. So these are the two arguments that a user is giving me, and I'll just do a system.out.println. The best way is what? Creating it as an integer and returning this value instead of printing it, so that user have an option to either print that result onto a console or maybe a web page or anything that we have already discussed during creation of the return type of the method. So let's do that here. So what I'm going to do is I'll just say it is going to return me a plus b. So that's what it is going to return me. Now I'll also create a subtraction method here, and I'll do a minus b for that. So int, two methods cannot have same name, that's why it's giving me an error. So a subtract, it should be a minus b. So this is a class that I have created, and in this class I have created two functions, addition and subtraction. So what I will do now is that I have already created this particular class. Now I can mark this particular class as final, and marking this particular class as final means what? It cannot be extended. So as for now, I will not write this public static void main. I'll just save it, and I'll create a calculator service for you. So there's a calculator. Yeah, there's a calculator service already created. So I'm using the same. So here comes the calculator class. I'll say, as for now, if I just create a normal calculator that is created, so I can just see this add and subtract method there. Calculator c equals to new calculator, and if I do a c dot add and then give two values 20 and maybe 30, so at that time I'll get the value, right? So system.out.println, so I'll get the result of this addition. So that's what I'm getting. I'll just run this and show you that. So I'm getting this result, right? So this, as for now, all looks good. Everything looks good, right? So what I'm saying is that this logic that is written here in add or maybe subtract and all, this logic is something that should not be hacked, or maybe this should not be changed. So that's why what I have to do is I have to declare this class as final. So I'll call I have already written a logic. Now what I will do is first I'll show you what happens if I don't mark it as final. So what somebody can do is somebody can extend this, and they can go here and then they will create, I'll create another class, create a class for this, and I'll say this calculator again is a modified calculator. Okay, or what they will be doing is they will be hack the calculator. Okay, so I'm creating a hacked calculator class which actually extends the calculator itself, and it overrides the function. So which function it is overriding? The add function. And what it is doing with the add function is that it is not calling that super dot add, it is actually returning you a minus b for add. Okay, so it's doing a minus b for add, or maybe it just returns you 0. Okay, whenever you are trying to add something, it is returning you 0 itself. So when I go to the calculator service now and try to create the instance of that calculator, so I can also see if I do a calculator c equals to new hacked calculator, it is all valid because you can create an object of parent, the reference of parent with the object of child. So calculator c1. Now if I see the c1 dot add and pass in 50 plus 50, so what I'm expecting the result of this int result equals to, so I'm expecting the result to be 100, right? 50 plus 50. And when I see the result, you just see what happens. The result, save, and there we go. So it is what? The result is 0. Now you might say, oh, no, you can get to know this by this calculator object and all that. You can know this, right? So see, in programming, there are certain things. There are things which can happen like this. So what is that? What I'll just do is I'll try and make this. Yeah, perform calculation or something can be written, and let's create that void calculation. So at sometimes I go at a very higher level, and this might take an instance of type calculator for calculator C, and then this particular perform calculation is trying to perform calculations for you. Like this is actually returning you the result, and then return c dot add, right? So this perform calculation takes a calculator instance for you, comma, takes the instance a and int b, and then it passes that a and b for you. And when you call the perform calculation or maybe perform addition or anything, so at that time you might see things like this. You have to just pass in the instance of the calculator. So what I will do is at this case, so this is what my simple example looks like. After that, I made it a bit complicated where I'm just performing a perform calculation. So let's make it static so that we can directly call it. Okay, static int perform calculation. So I'm performing some calculation. I give the instance of C1, and then I am trying to add what? 30 plus 30. Okay, and I get the result of this. Int result1 is equal to system.out.println. So 30 plus 30 is what I'm trying to know. Let's see what is the result of 30 plus 30 in this case. Okay, system.out.println, just to identify that result. At the end, I'm adding this line. So let's run it. What is 30 plus 30? It is giving me what? It's giving me 0, right? So because it is giving me 0, it means what? Somebody has played with our calculator. In perform calculation, we are passing in the instance, right, of this hacked calculator, which is the object C1 of hacked calculator. Somebody might just run into our code and then change the logic altogether. So this can be a problem which you might encounter while creating simple classes, right? So I have created a calculator. So this is a problem. I'll add it as a problem statement. Demo 5. A calculator is created, and I'm creating child of that calculator, which is hacked calculator. This child is actually modifying the behavior of the parent, right? So that's all valid. And then I'm creating a service class that's actually calling this. Okay, so if you don't understand this all concept, what is this perform calculator and everything, you can just remove it. Okay, you can simply remove it. As for now, I'll give you that. I'll write another the same demo. I'll call it as problem statement simplified first. Demo 6. Simplified. Same thing again. This is a calculator class where we have written the logic for addition and subtraction. And then we created a child class for that calculator and called it as a hacked calculator, or maybe an extended calculator, or maybe an advanced or modern calculator. We can create that. And then when we go to a calculator service, what we are doing is I'll just remove that the method that I have created. So perform calculation and all, just remove it. There's a calculator, and if I'm trying to calculate that with 20 and 30, same method c.add is giving me 50. If I use a hacked calculator, then at that time it is not giving me that. Okay, so I can simply directly go for a hacked calculator. Instance of the same can be created. Okay, it's a child of calculator only, right? When I do this, it is giving me a wrong result. No need of this. So how do I solve this problem? So I hope that you understand the problem. What is the problem? There is a class that I have created which is very important, where I have written the logic, and I don't want anyone to break this logic. Okay, what I want is, I don't want somebody to break this logic. So if somebody breaks this logic, it's like somebody has broken the trust, right? Imagine you're into a banking system, right? So if in a banking system something like this happens, maybe an EMI calculation or interest calculation, somebody has modified things like that. So what happens in that case? Your entire application might go down. So whenever you have a critical logic, a critical code which you don't want to modify, So the simple solution for that is that you mark the class as final. So when you mark this class as final, you notice that in calculator service you start getting the error. You cannot have a child class for that. So when you don't have a child class, you cannot override it. So it is as simple as that. So the solution is simple. Once the solution is given, then you start getting an error. I'll give you all of this so that you understand that it's the solution. Demo 7 solution final class. There's a final class. Then I try to create a child for it, and I'll write error cannot subclass a final class. Okay, select now cannot subclass a final class. So let's also make a note. When you have critical logic in your application and you don't want someone to break that logic, make sure you mark your class as final. Marking the class as final ensures the class can be used but cannot be modified, right? You can use that class but cannot be modified. That means you cannot subclass it and change the behaviors inside that. So once the class is final, it means that all the methods are final itself. Why is that? That's because you cannot subclass it. If you cannot subclass it, you cannot override it. So that's how it works. Now one question that comes into our mind, that is so in this case I had a calculator, right? So I don't want the add method to be modified and subtract method also to be modified. So if the class is not final, what is happening? If the class is not final, somebody might create a child of it and hack it. And one more point you can ask, why should I make a class as final? Why not create both these methods as final, right? If you make both the methods as final, even at that time also it will work fine. But what is the advantage of marking the class as final? See, that is actually a very good question if it comes into your mind. Now, if we are marking some methods as final, not the entire class as final. So what happens is, if we make this entire class as final, it means that no child can be created for this class first. And if the class is not having any child, that means if the class cannot be subclass, then there is no chance of overriding at all. So it is kind of what? It is a stronger lock that is acquired on this particular class as a whole, right? So these type of classes are specially used in terms of utility, securities and frameworks. Okay, and if you make only few methods as final, other developers can still extend your class, and they might accidentally break the logic written into your classes. They might accidentally break the codes. Okay, so only those methods that are marked as final will not be overridden. Other methods you can override. So in that cases you will be forced to keep a track on which method should be locked, which method should not be locked. So whenever you have a critical design in your applications, you make sure that the entire class itself is final, and nobody can extend it. If nobody can extend it, nobody can modify it. Yes, definitely you can mark methods as final, but in that case the problem that might come up is that you have to keep a track on the methods which can be modified, which cannot be modified. So that takes more effort and it will be more risky. So I hope it is completely clear to you what is a final keyword, like what happens when a final keyword is used with a variable, with a function and with a class. So in summary, final keyword used with a variable makes the variable as constant. If final keyword is used with a function, it does not allow that function to be overridden. If final keyword is used with a class, the class cannot be extended. So your class becomes a brahmachari class. I hope and now it is completely clear to you about the final keyword, and I think I have dived detailed in the concept of this final keyword. So in our next session, we will be talking about a very important concept called as the abstract classes. So tune in to this particular series, keep watching the series, and if you like the series, comment, like, share, subscribe. Thank you. See you in the next video.